Okay, geometry, we are going to start Unit 6, which is called Terrific Trigonometry. And that's what we're learning in this unit, all about trig. So we're going to do half of Lesson 1 today, and then we'll finish Lesson 1 tomorrow. Once you're done with this video today, you'll start your Lesson 1 homework. So here we go. Let's do the warm-up first on page 1 of your notes. Write each fraction as a decimal rounded to the nearest hundredth. So make sure you do that. You can see over here I have my little calculator. I have 2 divided by 3 is 0.6666 repeating, but rounding to the nearest hundredth. Remember, when you round, you get 0.6666, and it keeps going. You look at the hundredth place, and then you look at the number in front of it, which is above a 5. So therefore, this is going to be rounded to 0.67. 7 divided by 24 gives us 0.2916666. So this gives us 0.291666. Nearest hundredth is right here. Look at the number in front, which is a 1, so we will not move up for this one. So we will say 0.29. So make sure you round very accurately when you do your trig. Next, number 2, solve each equation. So the first equation, we have 0.8 equals 5.8 over x. You can do this a variety of ways. One, you could just say, well, let's put this over 1, and you can cross multiply. So 0.8x equals 1 times 5.8. So therefore, x equals 5.8 divided by, divided by 0.8, and you have 7.25. Another way you could have looked at that problem is you could say, well, 0.8 is the same as 8 over 10 equals 5.8 over x, and you could cross multiply, and you would get the same answer. B, again, the equation, x is in the numerator right there, so we want to isolate that x. Another way to look at these problems is to say, well, I just want to multiply by that 8.5 so that x is alone. So what I have then is 0.94 times 8.5 equals x. 0.94 times 8.5 is 7.99. So x is equal to 7.99. So a couple important things here is just to remember how to solve it. Solve these equations. Like in this problem, x is in the denominator, and so you have to move x to the numerator, and so we cross multiplied to do that. This problem, B, x is already in the numerator, so it's a bit easier to solve. So just take care of that. Make sure you remember how to solve equations, and then from here, make sure you remember how to round. All right, so by the AA similarity postulate, I know you remember that, it was just the last unit. So by the AA similarity postulate, a right triangle with a given acute angle is similar to every other right triangle with that same acute angle measure. So what that means is all 3 of these right triangles are similar because they have 2 corresponding angles congruent. They all have a 90-degree angle right there, and they all have a 32-degree angle right there. And therefore, we know that since these 3 triangles are all congruent right here, I'm sorry, not all congruent, all similar, therefore, we know that the ratio comparing corresponding sides would all be equal. And these ratios are called trigonometric ratios. So that is where it comes from. Trigonometry comes from similar triangles. And not just any similar triangles, similar right triangles. Okay. A trigonometric ratio, is a ratio of two sides of a right triangle. And so as we talk about these ratios, there's special names to these sides. So let's take this first triangle right here. We know that this long side opposite the 90-degree angle is the hypotenuse. That does not change. The hypotenuse is always the hypotenuse. But this angle right here is an acute angle. And in terms of that angle right there, this side way over here is called the opposite side because it's opposite that little acute angle. And this side over here, and then this side right here is called the adjacent side because it actually, remember what adjacent means. Adjacent is one of the rays that actually make that angle. And so this side is called adjacent. This side is called opposite in terms of the pink angle. Now, if I change that, let me get another color going here, and let's talk about this angle right here. This is also an acute angle, that little green angle. Now, if I'm talking about the green angle, this side changes, and it is no longer adjacent. It is called the opposite side, because it is opposite the green angle, and this side would be the adjacent side for the green angle. So as we talk about our trig, you have to keep track of what angle you're talking about. Because if you're talking about the green angle, this side is opposite right here, and this side is adjacent. But if I'm talking about the pink angle, for the pink angle, the opposite side is over here, and the adjacent side is right there. So let's do that again on this right triangle. So it has to be a right triangle when you use trig. Let's look at this angle right here. This is an acute angle in the triangle. The opposite side would be right there. And this would be the adjacent side for the green angle, in terms of the green angle. Now if I change my color, and let's go yellow, and I say, okay, this angle now. Go away. Interesting. All right, I'm not sure how to get rid of that. Maybe I hit that again. There you go. Okay. And if I talk about the yellow acute angle, this is the opposite side, and this is the adjacent side to the yellow angle. And now this side right over here, no matter which angle we're talking about, this side does not change. It is the hypotenuse, always. It doesn't change. It's opposite the 90-degree angle. We have another one here. I know this probably seems redundant, but this is the trickiest part about trig. You got to know your opposites and adjacent sides. So let's look at this angle right here. Opposite side. That would be right here, opposite. It's not touching it. The opposite side does not touch the angle we're talking about. Whereas this side right here is the adjacent side. It does touch the angle. The other acute angle is right here. So the opposite side would be way over here, and the adjacent side is right here. Remember, opposite does not touch the angle, adjacent does touch the angle. This side is opposite the 90-degree angle, so it is always the hypotenuse. That does not change. Okay, so remember a couple other things. The hypotenuse is always the longest side. It has to be the longest side. The longest side has to be opposite the biggest angle, and 90 will be the biggest angle. Another thing to remember, that the hypotenuse is always opposite the 90-degree angle, and the hypotenuse does not change. Okay, so here are our three basic trig ratios. The sine of an angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. So first of all, when we are doing trig, we always are going to do sine or cosine or tangent, but we're always going to do the trig function of an angle. So that A, that capital A, stands for an angle, angle A. And so when it says sine of angle A, that means we are in reference to this angle right here, angle A. And sine is opposite, so the opposite side to A over the hypotenuse, which is A over C. Whereas if I was doing the sine of B, well, now I'm doing it in terms of angle B. So now I'm up here at this angle. Which side is opposite of angle B? Little b over hypotenuse, right there. So as you do your trig, what you need to remember is that sine is always opposite over hypotenuse. You can remember that S equals O over H. Sine is opposite over hypotenuse. And remember, it's always in reference to an angle, so make sure you're choosing the right angle. There's a big difference. If it's the sine of A, it's A over C, and if it's the sine of B up here, it's B over C. So you have to be in reference to the proper angle in order to get your trig ratio right. Okay, next one. Let me erase some of that mess because I'm sure I'll make more mess. Okay, so all right, the cosine of an angle is the ratio of the length of the leg adjacent to the angle to the hypotenuse. So when we're doing cosine, look at this, we're doing adjacent over hypotenuse. It's different than sine. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. So here we're doing the cosine to angle A. Well, here's angle A. Cosine is adjacent, so it would be B. B is adjacent to angle A over hypotenuse. So this would be B over C. Whereas cosine of angle B, so now we're in reference to angle B, is adjacent over hypotenuse. So that's A over C. So look at, in terms of your angles, it makes a difference. It switches for sine. The sine of A is the same as the cosine of B. So you have to know what angle you're dealing with. So cosine is equal to adjacent over hypotenuse. And then tangent. Tangent of an angle is the ratio of the length of the leg opposite the angle to the length of the leg adjacent. So in tangent, there is no hypotenuse. It is only opposite over adjacent. And again, it's in reference to the angle. So tangent of A, if we're on angle A, we're down here. Then we do opposite over adjacent, A over B. And if we're doing tangent of angle B, so we're up here, we're in reference to angle B, then you need opposite over adjacent, and it's B over A. So it switches depending on what angle you're in reference to. You always have to know what angle you're in reference to. So I'm going to write T equals O over A. Okay, so now what we're going to do is you are going to sit back and I'm going to read you a story. So here we are. Once upon a time, a long time ago, there lived a poor girl on a farm. Her name was Wilma. She lived all alone. She lived a humble life that didn't involve too much change. She started each day tending her onion and carrot garden and ended each day with her favorite passion. She loved dancing. Every night, as the sun began to set, she would retire into her cottage, turn on her CD, and dance the night away. Meanwhile, up at the castle, Prince Fred was wondering what the rest of the world was like. He hopped on his handsome steed and set out to find out what others in the kingdom did with their days. He made his rounds and bumped into 1,000,000 different people, but nothing made much of an impression with him until he heard a sound. He rode over to Wilma's cottage and listened to the unfamiliar rhythm he heard. He knocked on the door and asked her what she was doing. She explained that she was dancing to music. He asked her if she would be willing to teach him how to dance, and she accepted immediately. Fred was a very slow learner when it came to dancing. It appeared that no matter how hard Wilma tried to get him into the right step, he would somehow lose the beat and wind up. Oh my goodness. Oh, all right. Sorry about that. It appeared that no matter how hard Wilma tried to get him into the right step, he would somehow lose the beat and wind up stepping on her toe. He left at midnight, but asked if she would mind if he came back for another lesson. Needless to say, the dancing lessons went on, and they fell in love. Fred soon proposed marriage to Wilma, and she, of course, accepted. King Fred and Queen Wilma continued their dancing hobby every Friday night. The only problem for Queen Wilma was that no matter how hard she tried to teach King Fred, he remained terribly clumsy. And whenever they went dancing, he would always step on Queen Wilma's big toe. Queen Wilma learned to live with this slight flaw in their true love relationship, but this big toe stomping was no laughing matter. So each Saturday morning, after one of their big dancing dates, Wilma would wake up early and sneak out of the castle to her favorite pond. There she would sit for an hour soaking her big toe until the swelling went down. As the years passed, the whole kingdom would watch the king and the queen's rituals of dancing and soaking with delight. Even after the king and the queen died, their love story lived on in the hearts of the kingdom. Of course, like all good legends, time changed the facts as well as the names. King Fred was remembered King Klutz, and Queen Wilma was remembered as Queen Sokotoa. And so that is the story of Sokotoa right there. Ooh, I can't write on this version. And down here at the bottom of the story, at the bottom of the screen, you can see, and Queen Wilma was remembered as Queen Sokotoa. Now, remember how we spell that, and look on your notes, and there it is, Queen Sokotoa. And the reason we love the story of Queen Sokotoa is because if you can remember Sokotoa, you can remember your trig functions. So what you have, first we have SOH, sine equals opposite over hypotenuse. Then we have CAH, C-A-H, so cosine equals adjacent over hypotenuse. And finally we have TOA. So tangent equals opposite over adjacent. And so you are going to hear me over and over again throughout Unit 6 and the rest of the year say, remember Sokotoa. When you get a test, when you get a quiz, when you're doing your homework, write out Sokotoa at the top of your paper, because at one point you'll think, oh, I know sine is opposite over hypotenuse. But sometimes your mind can play tricks on you and you're like, wait, is sine opposite or adjacent over hypotenuse? And you get all confused. So if you write out SOHCAHTOA and you remember SOHCAHTOA and good old Queen SOHCAHTOA, you can get your trig functions correct for the rest of your life. So let's move on. Okay, so what we're going to do now is we are going to find the trig ratios. Now, when you are asked to find the trig ratios, all you're doing is writing the ratio. And then, of course, you're simplifying the ratio if it simplifies. So here is your SOHCAHTOA right there. And so looking at this triangle, I guess I can make it a little bigger. Okay. First one is cosine of A. So your first thing when you're going to do your trig ratios, you're going to find the angle. Remember, it's always in reference to the angle. So, whoa, let me just minimize that. Okay, here's angle A. And so cosine, right here, C equals adjacent over hypotenuse. So cosine is adjacent over hypotenuse. Remember, the hypotenuse is always the hypotenuse because technically angle A has two adjacent sides. One is 24 and one is 25. But the 25 one is the hypotenuse. So that one doesn't count. So you use the other adjacent side. So therefore, we would say the cosine of angle A is adjacent, which is 24, over hypotenuse, which is 25. So your answer here would be this ratio, 24 over 25. It doesn't simplify, so we're done. Moving on, tangent of angle B. First, locate the angle it's in reference to, which is right here, angle B. And then tangent is opposite over adjacent. T equals opposite over adjacent. So in reference to angle B, the opposite side is 24 and the adjacent side is 7. So I'll say the tangent of angle B is opposite over adjacent. It doesn't simplify, so I'm done. Next, I have sine of angle B. So again, we're reference to angle B. Sine is opposite over hypotenuse. So write that down. S is opposite over hypotenuse. So opposite of B is 24. Hypotenuse is 25. So the sine of angle B is 24 over 25. And notice how I write this. The sine, the cosine, and the tangent, if you look in the original typed out writing, those are not necessarily capitals. But the angle, of course, is a capital, right? So make sure you write the angle as a capital, and then it equals that ratio. If the ratio can simplify, you would simplify it. But you would not make it a mixed number. It stays an improper fraction. Okay, now what we're going to do is we're going to use your calculator to find our trig ratios. But first of all, just notice that in the book, when it says to find the trig ratios, you're doing like this right here, unless it specifically says to use your calculator. All right, so how do we use our calculator? Well, let me pull my calculator up. Let me make this a little smaller so we can see it. Okay, so what we have here is on your calculator, you need to find your sine button, your cosine button, and your tangent button. All right, we're going to be using those. They're usually somewhere in the middle of your calculator. Mine are right here, but I can't really write on that. So let me delete that. Okay, actually, let me just clear everything. Okay, so use your calculator. I'm on example 2 here. Use your calculator to find the trig ratio round to the nearest hundredth. So look at the problem here. It says the sine of 52 degrees. That's an angle measure. So you're going to do sine on your calculator, sine of 52, close, and hit enter. Now, before you get excited about your answer, the first thing you need to do is you need to make sure that you are in degrees. You can see we're in 52 degrees, right? So you need to be sure your calculator is in degrees. So to do that, go to mode. I think most calculators have a mode. If you have a graphing calculator, you can see right here there's the word degree is highlighted on mine, whereas the other type of angle measure is called a radian. We're not doing radians right now. We're doing degrees. So make sure your degree is highlighted. And then you can get out of that. And then you do it again, sine of 52 degrees, and you should get 78, well, 0.788. All right, does it say where to round? Okay, round to the nearest hundredth. So you should get 0.79. That is the answer there. Let's do another one. Oh, I had it right there too. Awesome. Okay, more practice. Use your calculator to find the trig ratios below. Round to the nearest hundredth. So this is, you know, super simple. It's just practice using your calculator. So for cosine of 23, we're going to hit cosine 23, close your parentheses, hit enter, and you get 0.920, which would be rounding to 0.92. Tangent of 68. So we hit tangent 68, close your parentheses, enter, and we get 2.475. But we want to round to the hundredths, so there's my hundredths place. I look ahead of it. I have to go up. So this is 2.48. These should be approximates because we're rounding all of these, aren't they? Sine of 57. And we have 0.838. Here's my hundredth place. Look behind it, and we have 0.84. And this would be that one, this one, and that one. And there you go. We are going to finish these notes tomorrow. So that's the end in your homework. You're going to practice writing the ratios like here, like example 1. And then you're also going to practice using your calculator like example 2. That's it.